remember what did we first learn at 1.1? Completing the square. Okay, and then we need to always ensure that A is 1. Okay, so when we complete the square, it is to help us find the possible range of values of f of x. Okay, that was why we complete the square. It always help us to find f of x is greater or equals to a certain value. And the thing that we always use, what happened? Okay, is that we will always know that this is always true for any real values of x. Okay, this was mainly what was the whole thing about, and then also how to read your nature of points. Okay, whether it's maximum or whether it's minimum. Okay, if you have a formula book or a summary book, you should always, update it along the way as we finish the chapter. So maximum meaning coefficient less than 0. Minimum meaning coefficient of x squared greater than 0. So your smiley curve and your frowning curve. So turning point, you can always read from here. So your x coordinate always makes the bracket square 0, and then your y coordinate is just this value here. So this part here is your turning point. Okay, another word that they like to use for turning point is stationary point, but it means the same thing. Okay, because at the highest point or at the lowest point, that object that you see there, or rather the point, is stationary at the turning point before they change direction. So that's why they like to call it stationary point. Okay, then 1.2, we learn briefly about nature of roots through discriminant. Okay, which is your b squared minus 4ac. So we learned that there are 4 scenarios. Okay, scenario 1. Discriminant greater than 0 means there is 2 real and distinct. Okay, very small, huh? Real and distinct points. Okay, and then we also have scenario 2, where discriminant is equals to 0, 2 real and equal roots. Okay, the most common one is no real roots, but no real roots, there's also different scenarios. So let's call it scenario 3A. Or rather, let me call it 3. Okay, and then I will split it into 2 separate cases. So no real roots, you can have 2 scenarios. One being always positive. So if your curve is always positive, it must be a minimum curve with a greater than 0. Okay, the other one is where it's always negative. So your whole curve lies below the x-axis. So maximum curve, A negative. Okay, another word that they like to use for this scenario is lie completely below this is lies completely above. So this is what we have learned in 1.2. Okay, 1.3 is the application question, which is your problem sums. Okay, remember your tunnel, your, what do they call that? The parachute, not parachute. No, the thing that they shoot, what was it called? Slingshot. Okay, so the different kind of scenario they can give you, but it's asking the same thing. It will test you on your turning point. No, that one, remember you have a bridge, then you want to pass a truck over, then they ask you whether it can fit or cannot fit. But this kind of question, it's sometimes tested, sometimes not. So if you go to O level, right, for the past 5 years, there's only 1 year that they test this. So it's good to know the application, but it may or may not be tested. Okay, so turning point, they can ask you, but they will ask you what is the maximum height, what is the lowest point. So they will use other words instead of asking you for the turning point. They will ask you for the maximum height. What is the maximum height reached by the ball? What is the lowest point of your slope? So they will use other words to ask you the same thing. Okay, another thing they can ask you is the width. Okay, so when they ask for width, basically they are asking you to find the difference of the two x-intercept. It could be this or this, but they are asking you for x2 minus x1. So it's finding your x-intercepts, but finding the distance between the two of them. That one is between two coordinates, coordinate geometry. Okay, so this is roughly what they usually ask you, or they give you the x, find the corresponding y. So given x, find y, and vice versa. Okay, so application question, I can't prepare you enough. It is just all the different scenarios they can test you, but it is either turning point, the width, give x, find y, or give y, find x. But they phrase it differently. Okay, so this was your chapter 1 for A Math. I'm still copying. Okay, chapter 2 on equations and inequalities. Chapter 1 was quadratic function. I think I never write. Oh yeah, I forgot to mention there's also them asking you to find the value of f of 1, right? Which means sub x equals to 1 into the function. Okay, this one I think you know, but I just put it here in case you forgot that we learned this also. Okay, so as long as every time you think about a chapter, you can roughly have an idea of what is learned there, then you have a good understanding of the chapter. Okay, let's look at 2. 2.1, can you all remember what you learned? Simultaneous equation. Okay, remember simultaneous equation, there is always one equation that is linear and one equation that is non-linear. So for the linear equation, You always make one variable the subject of formula first. Okay, and then always sub the linear one into the non-linear. Okay, to solve for an unknown. So after you solve for the unknown, you are supposed to find the corresponding value, right? Either x or y. Always use the unknown and sub into the linear one to find the corresponding. Okay, to find the other unknown. Yeah, to the find. Okay, so for example, if I give you 2x plus 3 equals to plus 3y equals to 2, then of course you will want to make x the subject by bringing these 2 over, divide by 2. Okay, and then my habit is to make sure that I change to decimal so that it's easier to handle rather than fractions. Okay, but I leave it to you. If you are very good with fraction, you leave it as fraction and then you sub in. Okay, so this is making x the subject of formula. And then when you sub the linear one into the non-linear, it will help you solve for one of the unknown. For example, x. Okay, after you solve for x, the x values you find, sub it into the linear equation so that you won't introduce extra solution. Okay, to find the other unknown y. Okay, always pay attention if the question asks for coordinates or just solutions. So if they ask for coordinates, give me answer like this. Okay, if they ask for solution, you just have to write like this. Okay, the form of your answer is important. Make sure you express your answer in the right way. Yeah, I will. Yesterday, the 10-year series one I already loaded because we already sort of completed it. So this one, just take note, the form of your answer is where some of you lose marks, whether they ask you to write in coordinates or write in solution form. Okay, so that was 2.1 for you. 2.1, there's nothing new here except there's one non-linear equation. Okay, and you have 2 solutions. Okay, 2.2 is where they do the discriminant and level up. Your nature of roots. Okay, your nature of roots. Same thing, you will tap on discriminant. Okay, so how do they level up your understanding from 1.2? Okay, let me bring it down. It's the same old thing, but they give you more scenarios for that. Okay, wait, I'll come back. Okay, I just want to show you that they are clearly relevant. Okay, so this same part, what is different in 2.2 is that instead of writing 2 distinct real roots, they change it to line intersect curve at 2 points. Okay, they use geometry to explain the scenario. They tell you that your line cuts the curve at 2 points. So they are telling you discriminant is greater than 0. And then for this, they will say line is a tangent to the curve, which you know it means it just touches the line at 1 point, or they can use the word touches the curve, line touches the curve. So two different ways that they can say the same thing. The straight line touch the curve at one point, then we call it a tangent line. This straight line touch it at 2 points is not a tangent line. Yeah, so this is the tangent line. Okay, so they use other words to represent the same thing. So either this or this. Okay, this one is line intersect the curve at 2 points. And then of course the last two scenario is what I've written just now. Line lies completely above, no, curve lies. Need to enlarge, is it? Cannot see. Okay, so this one, to be precise, is curve lies completely above the line. Okay, I wrote wrongly. Curve lies completely below. Need not always be x-axis, but in this case, the line, whichever line we are given. Why behind? You all got something that you need to resolve? Like I turn, I hear you. I turn, I hear you. Yes, Raj?
What's the difference between intercept and intersect?
Okay. Intersection means where they cut each other. So like line and curve, they cut each other at these two intersection points. But when I say intercept, it is either cut the x-axis or cut the y-axis only, no other places. But intersection can be anywhere, okay, where the line cuts.
So intercept is equals 0.
Intersection. Depending on how many points it cuts. 2 points greater than 0, 1 point equals to 0. Yeah. So intercept, we know when you want to find the x-intercepts, you will sub y as 0. When you want to find the y-intercept, you will sub x as 0. So this one is slightly, two different words, and it's a common word that you will make mistakes with. Okay, so this one are common terms to take note of. Okay, then I think we also have one scenario where we say it intersects the curve. Okay, so when they use the word intersects means it can be 1 point or 2 points. So this is the combined scenario of these two. Okay, another one that is common is the one that we use never negative. Remember, never negative. So discriminant is less than or equals to 0. So this is a special case. Or never positive. Okay, these two leads to the same outcome. So there are many other terms they introduce in 2.2, but actually the concept is the same as 1.2. Yes. Never real and equal roots. Never real and equal roots means no real roots lah. They are never equal, so cannot be equals to 0. Never real means must be no real roots, so discriminant less than 0. Yeah. Okay, the other word to replace this is that they tell you the roots are real. So roots are real can be 1 real roots, 2 real roots. So this is another way that they are saying the same thing. Okay, so many words they can use in this subtopic, but you just need to know it leads to the same thing. So these two are the same. And then this is for this. Okay, so basically all the special words that they like to use is all here already. Okay, just make sure you familiarize. When you see the keyword, this is it. Okay, so that's 2.2 for you. If you ask me, I think this is the part that scares most of you. But there is another scenario where most of you will always lose marks, which is the one where they ask you to show, explain, or prove. Right? So when you are in this situation, you need to look at the question and decide what is it that you need to do. So for example, if you manage to find discriminant and it ends up being a quadratic. So let's say after you find your discriminant, maybe let's not use x, let's use k. They always like to use k. So you found that your discriminant ends up being a quadratic expression. Then what is the right thing to do? What is the right thing to do when your discriminant is a quadratic? What do you need to do? Complete the square. No, that's different from what. So you complete the square by adding your zero pair. Okay, and then these three forms your perfect square. And then you get a plus 2. So from here, you will say that for all real values of k, okay, you know that any bracket square is always greater or equals to 0. And then when you add 2 on both sides, you have found discriminant to be greater or equals to 2. Okay, therefore discriminant is positive. It has 2 real and distinct roots. Okay, so this is the special case where if your discriminant ends up not being a number, but it ends up being a quadratic expression, go and show this. Okay, another type is where it is not a quadratic, but let's say you get a linear. Okay, you end up having a linear expression for your discriminant. Then you don't know what to do with it because there's no bracket square. You can't lead the question to any conclusion. But I'm very sure somewhere in the question, they will give you, given that p is greater than half, they will give you some inequality somewhere in the question which you can use. So you have to use that from the question. This will be given in the question. And then you have to use that to help you prove. So how to use that? If you cross multiply, this is 2p. Okay, if you bring the 1 over, this is 2p minus 1. So can you see that this is actually your discriminant? And using the inequality they give you, you have proven that discriminant is greater than 0. So also same conclusion. Therefore, it has 2 real and distinct roots. So these are the special scenario where they ask you to show, explain, or prove. If it is a quadratic, use this. Okay, if it's a linear, they must give you something somewhere. Then you can use that to prove. Okay? So these are the 2 special cases. If they ask you, okay, so that means same thing. Before your WA, you all should run through your summary notes. Every time you do certain questions from 10-year series that's interesting or you always get it wrong, you can actually insert that into your notes. So how I study for O-levels is the same thing. As I do the papers, whether it's other schools' paper, our own school paper, or 10-year series, any question that always traps you, go and tag it. Okay? And then when it's before the exam, run through these questions that always traps you, so that it reminds you that, oh, when I see this, this is what I do. Okay? So you all need to collate all these things together. That's why you need to do filing. That's why you need to do note taking. Not that math you cannot revise. Okay, so actually, eventually your 10-year series will be full of tag or color code. So as you do, if certain question always traps you, go and highlight it or go and put a tag there, so that before the exam you revise those that traps you always. Okay, same for your exam paper. So you can revise math. Okay, next one. The very, very last one we learn is 2.3. Okay, 2.3 is quadratic inequality. So remember, if your discriminant that you found from part A, part B, that you want to solve ends up being a quadratic expression. Okay, and it's not a proof question, it is a solve question. Then don't need to go and complete the square, you will need to factorize it. So go and factorize it. So the second step that you need to do is to factorize it. Okay, and then next thing you do is you sketch out the shape. Okay, you sketch out the shape. So you know this is 1. It is positive, so it's a minimum curve. And then you input your x-intercepts. Okay, input your x-intercepts, which is -2 and -1. Okay, so after that, you have to follow the instruction of the question. Let's say this question happens to be no real roots. So you know discriminant is less than 0. So follow this. Okay, this part. And then you look for your solution range. So whether it's the bow or the tail. Okay, don't go out telling people bow or tail. Nobody will know what you're talking about. It's just my simple term to relate to the answer. So look for the solution range. I want the part of the curve that is below the x-axis. So in this case, it's bow or tail? Bow, this one. So your answer is trapped between your -1 and -2. All the solutions are here. So you have to run through the steps. Okay, what if your quadratic expression cannot be factorized in this way? What if it's not a nice one? So example, okay, what if I cannot factorize it? Then you will solve for the x-intercept. Oh, this one no, cannot solve. Sorry, yes, use your quadratic formula. Okay, if it's not a nice answer, you could still use the x-intercept and solve the problem. So in this case, what should it be? It's a 24, is it? 1, 2, -5. So your two solutions are 1.45 and the other one is -3.45. So same thing, you will put the x-intercept as these two. So even if it's non-factorizable, don't worry about it. You can still solve for the x-intercept and look for the part of the curve that you want. So if it is above, then it's the two-tail. Your two solution will be less than 3.45, more than 1.45. Okay? So even if it's non-factorizable, it is fine. You can still find the x-intercept, put it on your sketch, and then solve it. Yes.
We cannot show the master that part, right? The factorization part.
This one we need to.
No, like the other one. Like,
This one?
is it a quadratic formula?
You can show to find the 2x intercept.
But then it isn't equal to 0. They might like penalize us.
Oh no, we are just finding the point where it is equals to 0. So they won't penalize you finding the x-intercept. Yeah, so it's okay. Okay, and then of course when it's maximum, you will look for the above 0 or the below 0. So there are many situations. Just make sure you find the correct part. So you all cannot memorize minimum, above means it is tail or bow. You cannot memorize like that. You sketch it out and look at where is your solution. Okay? So quadratic inequality, that is it.